Hello my friends and welcome. My name is Dennis and as you probably know I'm Boeing 737 captain, and today we are here in the flight simulator in the cockpit of Boeing 737 NG. That's exactly the same airplane that I fly. Nice airplane, actually one of the most safe airplanes ever built. And today we'll discuss with you the engine failure, a very tricky one actually, because we'll have the engine failure or engine damage just after we want. So let's start. Let's prepare this cockpit. So we are now in Boryspil around 36, right? Very nice airport. Why are we here? Because that's my home base. So Boryspil is my home base, and let's quickly set up the cockpit, set up everything. So we don't have anything here. We don't have the route. We don't have anything. So index, position. We need to press OK, baby. It's the airport ICAO code. So here once again let's fly to Odessa, Uniform Kilo Oscar. The flight number I don't really need it, so runway 36 right is here, and we'll have the departure of from runway 36 right, maybe Basor. Sorry, it was here, Basor 1 Romeo. And activate, execute, so we have something on our navigation screen here, our departure actually. So climb straight ahead and to the right through this point, then to Bravo Romeo Papa. That's our VR in Boryspil, then continue to other points. So we have everything here. It's okay for us to have it just here because it's just a joy flight, my friends. So don't use this video as your guide if you want to fly the real airplane. I will not recommend you to use this video. So actually it's prohibited to use this video. So I'm doing this just for the joy purpose, my friends, just for the joy. What else? We may request the data. Usually you put it on your own. So you have the load sheet, you have everything, you know how many passengers you have, passengers. But we'll load from the, let's say, a car system. So I'm gonna load, execute, so we have everything here. For cruise flight, let's press wind 203, so direction is 200, and 3, 4, and 1. Let's select the, let's assume that we calculated the takeoff parameters, and let it be the rate 2 and reduce of 35. So actually the full rating of these engines is 27k, but we have the second rate, so we have 22k for our departure, and we also have the so it's our rate, the second rate, and also we have the assumed temperature of 35. As you can see, the outside its temperature is plus 14, so we have assumed that outside temperature is 35. That's why we have this lower rating compared to the rate thrust, and that's okay. That's normal thing for departure. Let's do the takeoff with flaps 1 as usual, and let's put CG, let's say 25 point, because I don't have load sheet with me, so let it be 25.5. I'll press it here, and let's use the QRH speeds. Very simple, very nice. Go to the next page. We'll perform the NADP2 procedures. So 800 here for acceleration, 800 here for thrust reduction, and engine out acceleration. Altitude, we have in inches the hectopascals. Let's turn to have in inches, let's turn to hectopascals. That's what I was going to say. And on a minimum we'll select the 800, and that's our engine out flap retraction altitude. So we scroll until we reach 1230 feet. That's our reference. So at this altitude here, Barrow, will have the flaps retraction in case we have the engine failure. Let's set the MCP, and so we have the course of 356 everywhere, because that's the runway heading actually on the course. And what is our V2 speed? Let me check. Yeah, 163. I already set it to 163. The auto throttle on, the LNAV with nav. Oh, sorry, I forgot the flight director. So we are not following what is happening? What is, no, 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 I don't want to go. So we are not following the standard Boeing procedures. I wonder why toga was pushed. Okay, we'll just stop it here. So yeah, rejected takeoff. So we are not following the Boeing standard procedures. We are following our own procedures because, as I said to you, okay, I'm going to select the other flight director. So LNAV, VNAV, please. Everything is set. Because the point of this video is to speak about the engine failure in particular. So I'm not going to prepare the cockpit in a proper way here, but I have the videos on my YouTube channel where you can check out the CDU per flight and many other things. So basically here we need to select the transponder, or just accidentally press the test, let it be. And what else? Maybe terrain, airport, I'll choose. Okay, TCAS test pass, that's fine. Let's fly, my friends. Let's fly now. So we're clear for takeoff. Let's turn on the lights, what we need for our takeoff. As for overhead panel, everything is done, so let's assume we perform the before takeoff checklist, and yes, flaps 1, of course. So we are not following the standard Boeing procedures. So actually here we need to perform the pre-flight, before start, before taxi procedures, before takeoff procedures. We don't need it to be in this video because it will be, otherwise it will be very, very long. Now I need to discuss with you the engine failure. In our case it will be probably engine damage, because it will be a little bit more interesting for us to fly this airplane. Here I'll just got you familiar with the flight instrument, with the engine instrument, sorry. So here we have N1. That's your fan RPM in percentage. So actually this big fan that you see on the airplane, it's actually rotates and creates most of the thrust of the engine. So here we have its rotation, and here we have green marks. That's our reduced thrust. So in case you have the engine failure, if you still maintain this reduced thrust, you'll achieve nice climb gradient. You'll achieve the rate, good rate, even on a single engine operation. But if you need extra thrust, you may press the toga button once again, and you'll have the full rated thrust for the rate setting, let's say. So you have this maximum rate thrust, so you eliminate this reduce correction. I hope you understood. But you'll never go through that maximum rate thrust, so you can apply more thrust like advanced full forward, but probably will hit the overboost. If your engines are 27K rated, you may not enter the overboost. But if your engines are lower, let me check, we have 26K, the possibility to enter the overboost is quite high. So FCTM, the Flight Crew Training Manual, doesn't recommend for pilots to overcome the rate thrust. Let's say in our case it's the rate 2. We may not set the rate 1 because it's not recommended by Flight Crew Training Manual. In one case you can do it, in case you have the risk of colliding with obstacles. So if you have the negative vertical speed, so you are decelerating, your speed is dropping, and you are coming down, and you probably may hit the obstacle. In that case, yes, advance thrust levers full forward, and yes, you may go to overboost conditions. But in normal engine out procedures, you don't need to overcome the current rate settings for your flight, because that includes the minimum ground control speed and air control speed that's required for your airplane controllability, let's say. And basically, what should we do next? We just fly. Let's fly, my friends. So I'll just press toga once again. Okay, we have N1 toga. Let me control the direction. I just accidentally pressed the toga before. Now we are okay with it. I'll just click on first officer's instruments for you to see everything. So we have speed alive, as you can see, enough and enough armed. Now we have 80 knots, that's fine. So now it's, so I'll press, so sometimes, yes my friends, I will use pause here. So I want to explain to you. So after reaching 80 knots, it's your high speed reject takeoff time. So you may reject now, in this case, after 80 knots till V1, only in case of engine failure, fire warning, aircraft unsafe, unable to fly, or predicted wind shear. V1, what is V1 speed? It's, someone told me that it's decision speed. No, my friends, it's first action speed. At this speed you need to perform your first action, so before this speed or at this speed you need to perform first action to stop your airplane. So actually you call, the pilot monitoring calls few knots before reaching V1, and at V1 on Boeing 737 you need to close thrust levers and disengage the auto throttle. So you disengage the auto throttle and close thrust levers, it's the simultaneous action. So here it's our high speed reject takeoff in case of engine failure. But let's continue, because we'll have the engine failure after reaching V1. Oh, it's shaking. nice flight simulator. Actually, I'm waiting for the same PMDG model on Flight Simulator, Microsoft Flight Simulator 2020. So now it's our go speed. Okay, we are almost at V1 speed over here. Sorry my friends, I'll turn my phone off because so many messages, and also from you my friends. I have so many messages everywhere. So we are reaching V1 here, so it's too late to perform the first action. Yes, so in case of engine failure we now need to perform the first action, because we are, let's say, V1 rotate. Okay, it's the same speed because the runway is dry and they're usually the same. Now I need to rotate, but in this case the rejected takeoff is not the option anymore. So we have engine failure, it's more safe to continue the takeoff. In case you have the engine failure or engine damage or engine fire, you just continue the takeoff, and in case you lose one engine, you need to rotate the airplane in a more slower manner than with two engines, because you just lost some part of this pitch up moment, because your engines are mounted under the wings and you lose one engine. And of course you have this side moment as well, because you have the shoulder, you have this lever, you have some symmetrical thrust, it's okay for you. But if you lose one engine, of course the other engine will rotate you, creating the yaw moment. Now let's do it. Let's go to this flight simulator. We don't need this artificial horizon anymore. And by the way, you need to do it like this. In case of engine failure, the engine parameters will appear here on a lower display unit. But I need to go to our MCDU, actually to the simulator setting. We go to PMDG setup, aircraft, failures, electronic engine, okay, programmed, okay, engine 1 severe damage. Let it be, engine 1, activate, yes. So now we have activated the failure, and now let's see what happens. So we are at V1, as you can see we have the reduced, why is DTO, delayed takeoff thrust, it should be RTO, but anyway my friends, it's actually a reduced takeoff thrust. So it depends on the model, sometimes you have DTO, sometimes RTO. So my friends, let's unpause and let's see what will happen to this engine. You'll see not only failure but the engine damage itself. Let's unpause. Whoa. So you see, I paused it again. You have the engine fail indication and you have 0 and 1 rotation. So the possible cases is the maybe compressor blown up and your fan is stuck, or maybe you lost your fan or something. But actually if you lost your fan, you'll have maybe dashes or something. So if you have the engine separation, you'll have blank display here, or probably you'll have dashes. In case of engine failure, you will have the N1 rotation and 2 rotation. But here, let me press I'm sure that it should be working. But here you can see no N2 rotation, no N1 rotation, so the engine is jammed. And it's not good because you cannot restart it. So something went wrong with the engine, maybe it's just stuck. And yes, it's called engine damage, and there's specific memory items in that case. So possible cases: engine failure, engine damage, engine separation, and engine fire. In case of engine fire, you'll still have nice N1 rotation here. You'll have residual thrust, and that will help you to climb, to accelerate, and then you can shut down the engine manually, of course. Then you're ready, and you can extinguish the fire. You may extinguish the fire, and you need, of course, to extinguish the fire. Here, in the case of engine damage, you are unable to do anything, so we fly only with one engine for the rest of your flight. And of course, at this speed, we need to continue. So after one, we'll continue and follow, of course, the flight director guidance here. All right, I'll try my best now. So we have automatic disengagement on the auto throttle. Come on, I applied full nose up. Come on. It's the simulator, and we are heavy, my friends. We are very heavy. Let me pause once again. So I applied full nose up actually for my stick. Maybe I have different, maybe I mistrimmed the airplane because we have some maybe different trim setting. Maybe I didn't put it as it should be during the takeoff. What you need to do is you need to pull the yoke up and until reaching, let's say, 8 degrees. So now we are climbing, okay, we are flying, but you need, then you are still on the runway, to pull it a little bit, and with a rate of 1.5 degrees, that will take you around 5 degrees to reach 8 degrees. You need to reach 8 degrees, because at 10, if you are flying Boeing 737-900, at 10 degrees you'll have the tail strike. If you fly the Boeing 737-800, you'll have the tail strike reaching 11 degrees. So we fly 800 in our case, and you can see we have nice rate, but we have reduction in airspeed, which is not very good. In our case, we have the positive rate, and we can retract the gear, positive rate, gear up. And that will, of course, reduce the aerodynamic drag, the total drag, and we should climb with with greater vertical speed. Let's unpause once again. Okay, can hardly control the airplane. Maybe I should trim a little bit up. I don't know how to do it on my Joy, so that is why probably I should trim it a little bit here. Pause once again. Let's try to press the toggle a second time, and let's see what happens to this setting. So that's actual our reduced takeoff thrust. Okay, let's press toggle once again, and let's see what will happen. We'll have the thrust for full rate thrust. And we need, in this case, we don't have the auto throttle. We should manually advance the thrust lever. All right, here we go. Let's pause once again, and let's see our deviation. I didn't apply the rudder because of the side moment, because you have just one engine working. You should have the side moment, so you have it. And because I didn't apply the rudder, I don't have the rudder setting, so I just have my joystick and this the rudder movement. And I was talking, I was pausing, so I didn't apply the rudder. But on real airplane, on a real flight simulator, you actually need to apply the rudder quite a lot to compensate this side moment. And here on navigation display you may see the track. It's actually 351. It should be 356, the same with your runway heading. And you need to turn now to the right to go back to your departure track. Now let's do it, because we are deviating to the left. Let's silence this warning. And what you have, because you have lost the engine generator, of course, if you lose the generator, and you lose many of the system like hydraulic, engine driven, pump as well. So just fly, my friends. Let's fly. Let's silence everything and continue to fly the airplane. I'll turn a little bit right with my radar. Hopefully we should go to our departure line. No, have some side slip probably. Banking, not good. Well, we already passed the 400 feet, so now we actually at 500 feet with nice vertical speed, 500 knots, 500 feet per minute, sorry, not 500 knots, with a speed of 174, which is quite lower than we should. But actually it's okay, it's V2. Our V2 speed is 163, so we should be between V2 and V2 plus 20 during our initial climb. That's okay, so this speed is quite fine. There is no trend for deceleration, so it's okay. And passing 400 feet on radio altimeter, here the airport elevation is 430, so we should wait until reaching 830 to perform the first action after you have the engine problems. The pilot flying after passing 400 feet, he or she calls identify the failure or check engine status. And the pilot monitoring, he or she checks that we don't have the N1 rotation, we have the engine fail indication, and we also sorry, I don't know why it automatically didn't appear automatically, so I have crossed with the start, but actually we cannot restart the engine because we don't have N2 rotation. No fuel flow, so yes, we have engine damage, and pilot monitoring calls the engine damage, and pilot flying calls for memory items, and he actually, or she, who is pilot flying, actually starts the memory items, because the first items there is to disengage the auto throttle over here, and just click this button. It's already disengaged, and you should close the thrust levers, the effective thrust lever. Let me check. And you, before closure, you just need to confirm thrust lever number 1 with your colleague, with your, let it be, we are flying as a captain, so call to your first officer, confirm thrust lever number 1, and he or she says okay, confirm. And by the way, guys, here we don't have the lateral navigation, so before even starting memory items you need to call for heading cell. So we call for heading cell for some kind of lateral mode. So before starting memory items, call for heading cell memory items. So that was, yes, so I'm continuously talking. It's the joy purpose videos on real life in flight simulator called heading cell memory items, or whatever you have. If you have straight line flying long way, now we have turn to the right. It will be very soon, so in our case it's better to perform with the flight with heading cell and continue climb to, let's say we don't need to reach this 10,000, so we may reduce to minimum safe altitude in the sector, and for minimum safe altitude we may check this chart, and in that case we'll have probably 1,700, but we already deviated to the left, so in our case I will select the 3,000 feet. So 3,000 feet is quite fine for us to achieve here. So reset here 3,000 feet. What else at 400 feet? You need to perform, yes, select the lateral mode and perform memory items. What is memory items, or what are memory items? Here I'll show it to you. So engine fire or engine severe damage or separation, it's the same memory items for all of these failures. One of more of these occur. Engine fire warning, no, we don't have engine fire warning. Airframe vibrations with abnormal engine indications. Yes, we have abnormal engine indications. Engine separation, no, it's not our case. So, but we have abnormal engine indications, and yes, that's our case. Auto throttle disengaged, it's already been disengaged. Thrust levers confirm close. So that's what actually the pilot flying is doing. He does it. So thrust lever confirm closed. Okay, so you need to confirm all the items with your colleagues in this with your colleague. Next, thrust lever. Okay, auto throttle disengaged. Thrust lever confirm close. Engine start lever confirm cutoff. That is what first officer in our case is doing. So he or she places his or her hand here and asks confirm confirm engine start lever number 1, and captain responds affirm or confirmed. Now we have closed the engine start lever number 1. What is next here? Engine fire switch confirm pull. Engine fire switch. So he or she places her or his hand here and said confirm fire switch number 1. Captain saying okay, affirm, confirm, and okay, we need to press this button first and then pull, and cross check again with the parameters. So before performing these memory items, cross check that you have active engine number 2, not engine number 1, not to shut down the working engine. There were several accidents where pilots accidentally shut down the wrong engine, because yes, you don't have the engine failures during your normal operation. That is why, of course, you are under stress condition. And this you need to remember. So if you have a fire warning, in case you have this sorry my friends, oh, why it's not moving? Okay, so you have this fire warning over here. You need to rotate this handle and wait for 30 seconds. If you have still fire warning, rotate and wait again for 30 seconds. And check out that you have the bottle discharge over there on fire system. So if the engine fire switch or engine overheat light illuminate, rotate, hold on for 1 second. After 30 seconds, rotate and hold. And after the next 30 seconds, if you have engine fire conditions, it means that you have unextinguishable engine fire. And let's go for the next step. So memory items completed here, and yes, at this point we should stop, my friends. We should stop, and you should call, if you have the time, you may call to air traffic control and say, in our case it's Mayday, 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 pilot block 1, we lost 1 engine, climbing straight ahead 3000 feet. Why it's emergency in our case? Because we are not following the standard instrument departure. So I would suggest, I would call myself Mayday in this case, because there may be different airplanes flying from different direction here, and you will not follow your standard SID. You'll just climb straight ahead to reaching 3000 feet. That what would you do here? And there may be different airplanes, and that will attract the attention of the air traffic control. They would change the other airplane routes, and and now you are very close to the ground actually, and you don't know what may happen to your other engine. So in my case, probably I would call Mayday in this case. It depends on your local regulation, my friends. You have the list of what then you need to call Mayday, and one of those lists in many of the airlines you need to call Mayday. Then you have the engine failure or engine damage after departure, and of course if you have the fire, it's Mayday as well. Now let's just pause and fly again. And you saw what happened. We have the automatic increasement of our speed. So after passing 1230, remember we put the 800 feet here, on MCDU. Here it's it was on a takeoff page, so takeoff page, we put 800 over here, and we have the automatic, because we put it there. In case of engine failure, we have the automatic increasement for bag up. So bag up means the bag here, the magenta bag, it is automatically set to flaps up speed. And yes, then you reach this speed, you need to retract the flaps, then you need to select the level change over here, and after that you go to N1 page and you select the maximum continuous thrust. Let's do it. So now we just fly straight ahead. I'll just unpause the simulator, and as you can see, the flight director is going down. Hope you may see it. So just gonna fly like this. The flight director is going down because we need to increase our airspeed to this bag up speed. Now almost not climbing, so I'll increase the vertical speed. I'm flying manually now, but I might have selected the autopilot after passing, let's say, 400 feet. I may select actually the autopilot, why not? Select the autopilot on. Let's see what happens. I don't trust this flight simulator because it may go to descent right here. Probably. I don't know. What happened to our heading? It's 356. Okay, we deviated to the right a little bit, so that is why. Okay, we're reaching flaps up speed. We may select the flaps up. Good. Flaps up, and waiting for flaps up, no lights here. Man, where are you going? It's going to the left very sharply. Didn't follow the heading cell. But anyway, flaps up, no lights. Now set level change. And here you need to set the maximum continuous thrust over here. So it's 97%, and you of course need to reduce it. 97.1. Come on, it's very sensitive. Let it be like this. And now you're reaching 3,000 feet, which is good. Alt acquire. At this altitude, just increase your speed a little bit more to have the gap. I would prefer plus 10, or let it be 240 because we are quite heavy. And the speed will increase because we don't have the auto throttle operation. It will not reduce the speed automatically. So here, even with one engine, the airplane would accelerate. So we need to reduce our speed here. So reduce the airspeed, and it is good. Let me pause it here because we need to check our fix from Bravo Romeo Papa. It's to check out our minimum safe altitude in the sector of 25 nautical miles. So soon we're gonna reach the 25 nautical miles. In that case, we may ask for vectoring to maintain this altitude of 3,000 feet for another approach or other conditions. So let's just fly the airplane. So we continue fly the airplane, and air traffic control tells us turn right heading let's say 170 or something. Yes, let it be 170, and airplane will fly with 170. And also you need to limit your bank angle. If you are at V2 plus 15, you need to limit your bank angle down to 15 degrees. If you are at V2 plus 15, you have the limit of 30 degrees. And now little by little we are turning to the right. Yes, no, something wrong with autopilot, I think. Why it's not flying? It's flying but with very low bank. Come on, What happened? Okay, I'll just disengage the autopilot and I'll just turn manual. And let's try it once again with autopilot. No, it's actually reducing the bank. I don't know why. We have the 25 degrees selected here. Let's select even more, 30 degrees. Let's see what happened. But it's just a flight simulator, I don't know why. Maybe because the engine is working on the right side, that is why it's very hard for airplane to turn. So let me help the airplane a little bit. So I'll put the rudder a little bit to the right. Actually, you need to trim your airplane after you have the engine failure. You are stabilized, you took off, you press the rudder pedal, you stabilize the airplane, and then you need to trim the forces when you fly. So it's also the main thing, actually, my friends. No, it doesn't help. Come on, even more. Does it help? No, I don't think it is a problem there. Now the speed is dropping, so I add some more thrust. So then you retract everything, you retract the flaps. You may go to non-normal checklist, which is our engine fire or engine severe damage or separation. So you read all of these, which we already performed, and that items were already performed. So you read them once again, and that here down to this dash line, you need to memorize on your memory. You need to do it by heart. So in this case, you need to disengage the auto throttle, close arse levers, then engine start lever affected side, confirm cutoff, then fire switch affected side, confirm pull. If fire condition persists, go and rotate it for one and hold for 1 second. Start timing, wait for 30 seconds, rotate for other direction and hold for 1 second. So that is how you basically do. So you have engine fire indication, rotate, and you'll extinguish, probably you'll extinguish the fire. Actually, the probability to extinguish the fire is quite high for jet engines. Then you go with the checklist. So now we have time, you are flying around, and you have the checklist. Choose one. High airframe vibrations occur and continues after engine is shut down. I think we don't have the airframe vibrations. High airframe vibrations does not occur or does not continue after engine shutdown. Yes. Goes to step 7. Isolation valve close, and you go to your cockpit and you proceed with your isolation valve. Come on. Close. And then pack switch affected side off. You go with the pack affected side off, pack number 1, and that all is done by first officer. This step causes the operating pack to regulate the high flow in flight with the flaps up. Next we have the APU bleed air switch off. It was off during the takeoff, and yes, go to the next. Choose one. APU is available for start, APU is not available. We'll go to APU is available. So let's go to the cockpit and let's start the APU. APU available, as you can see in the checklist, APU start. Then APU is running, APU gen switch on. So now we should wait for the APU. We may check the APU AGT. There is no specific numbers for Boeing 737 NG. So yes, it's a normal thing to have low pressure indication. And now we should see the arrow, okay. And wait for the blue light to appear here. Let's check the flight parameters. Oh, the speed is high. I need to reduce the thrust. Ouch, still new this flight simulator. I'm very rare flying this flight simulator. If I was in a real cockpit, it would be very easy for me to switch all the things, etc. But in this flight simulator, I'm alone, my friends, and yes, it's very hard for me to fly even this during this quite usual case with engine failure. So you see that I forgot to trim the airplane because I don't feel these forces on the rudder pedal. So I forgot some of the things on this flight simulator, because if you fly two pilots on board, so you work like a team, one says one thing, the other say the other thing, and you fly like you actually like orchestra, I would say. You perform one thing, the other guy performs the other thing, so step by step. Here I'm alone at this cockpit and I don't see lots of things around me, so it's quite hard for me. Sorry. That is why we all flown 25 nautical miles from Bravo Romeo Papa, but it's okay, because I don't know why in this case the autopilot turns the airplane with such a low bank angle. Don't know. Actually don't know. But my friends, it's just a toy, it's the flight simulator, so we are not following the realistic conditions. Let's check our APU. So we have generator on according to checklist. Let's see, we have then APU is running, APU gen switch affected side on. Let's go, let's select it on. And why do we have the autopilot engaged? Because the autopilot A is on the left side, the left generator. If you have the problems with right engine number 2, and you select the APU generator on the right side, you will not have this autopilot disengagement. That's the usual thing, and nice thing to have it on this quite I think it's quite realistic flight simulator. I mean, per 3D and PMDG model itself. All right, I'll press pause and let's go to other step. Balance fuel is needed. Let's check our fuel. It's here. We have that central fuel and central tank, so we don't need to balance the fuel. That's okay. Then transponder mode selector TA. Let's check it out. Transponder mode selector, we go to TA only. Yes, because, and that will not show us the resolution advisory, climb, descend, because our performance will not be as same as with two engines. So we'll omit the traffic not the traffic advisor, but a resolution advisor. We'll go with a traffic advisor only. Isolation valve after the fire has been extinguished, auto. So we hadn't had any kind of fire, so we go with the isolation valve auto position. Plan to land and the nearest suitable airport. So yes, isolation valve, of course. This step ensures bleed air is available to both wing if wing anti-ice is needed. In our case, it's not needed. Plan to land at the nearest suitable airport. Do not use the FMC performance prediction. Go to the one engine and operative flying checklist on page 734. Let's switch it on, but we will not follow it at first, my friends. Let's see why. We've done with our emergency, my friends, so we've done with the memory items, so we secured the situation. Now we can easily fly the airplane. Yes, the speed is quite high, so I'll reduce it a little bit down to the up speed. I think we don't need this gap anymore because it's increasing the speed and it's very sensitive here. What we need to do, we need to perform the after takeoff procedure here. So lights, yeah, let's fly with the lights because we are very low. The auto brake off, of course. Engine start, I didn't select them on, so engine start switches continuous, from continuous to off, sorry, and here landing gear to off. Let's perform the after takeoff checklist. I don't have it with me, so after takeoff checklist: engine bleed on, PAX auto, pressurization normal, landing gear up and off, AS and flaps, and altimeters okay. So let's be like this. We are flying as for the joy purpose. So my friends, sorry, I don't have the time now to search for my checklist. It's in the same courage, but I don't want to switch the page from the one engine operative checklist. Sorry about it. So we are flying, and at this moment we still do not have the communication with our flight attendants. because we need first to negotiate what should we do next. So we have only one engine, and we need to request the weather. So we request the weather in Boryspil airport, and also we need to consider whether we are gonna land or wait, or whether we should wait and burn the fuel. Depends on the kind of failure and kind of situation you have for particular failure. In our case, I'm just gonna land or wait because we don't have the tire problems. You may also call, just if you rotate at a very high speed, you may confirm with the air traffic controller that we rotated at a high speed and that it may exceed the maximum ground speed for the tire certified. So please check the runway for debris, and of course they will check the runway for you to be sure about it. But normally you rotate at V2 with a gap V2 plus 20. So it was for us from what I saw, and we are okay with it. Let's pause, come on. Oh my god. Yeah, so I have the checklist, one engine operative flying, and before reaching this checklist we may come to conclusion about what should we do. We need to check the weather, tune the ATIS frequency, we need to negotiate with air traffic controller which runway should we use, which is more suitable for us, which runway is available, what kind of approach should we expect. In our case, let it be the weather is fine, and expect the ILS approach runway 36, right? So it's okay for us. Let's expect this approach. By the way, my friends, the good CRM practice is do not announce your final decision first as a captain. Listen to your colleague, your first officer. Try to ask different questions. What do you think about this situation? What should we do next? Do not ask, do you think we should turn to the right? Because this is the not good question. Try to ask which direction should we turn, because if you say to the right, for example, first officers would say yes, confirm, to the right. So you need to ask the questions without options. So which direction, what should we do in that situation? Do not ask whether we should climb flight level 50, whether should we descend 2,000 feet, because that questions will attract the confirmation basis, the confirmation answer. Try to ask the question and try to obtain the decision from your first officer, and then you may include it to your decision, or maybe you'll hear something that you haven't even think about in this situation. So try to analyze everything and try to get all the resources possible, especially from your colleague. And the next thing you need to do, you need to call number one to cockpit immediately, or yes, number one to cockpit. Depends on the airline you fly. You have different callouts, and basically you tell them that we have the failure. So we have, it depends also on your airline, you have different types of communication with your flight attendants. So first you tell them, okay, we have the engine damage, we lost one engine basically, and we're flying back to Boryspil. So I will tell to passengers just right now that we are diverting back, and it will be the overweight landing, but nothing special about it. So do not prepare for the emergency situations. We already calculated the performance for the runway. We should be quite okay, quite safe, because my friends, for the Boeing 737, the engine failure, it's not the emergency case. So it's a usual thing. So you don't need to call the flight attendants to prepare the cockpit, the cabin for evacuation. So it's a normal thing for us to land with one engine. It never happened, especially my airline, it never happened to Boeing 737 NG, but in many of the airlines it may happen, and we always train to deal with this case. So just turn to the right here, and you basically tell the time where you're gonna perform the approach, and that's it. And we have also specific callouts for our flight attendants before, if we have some emergency. So basically call. And yes, briefing completed. After that, with the flight attendants, after that you may call to passengers and tell them, try to calm them down. And what next? Then next we have one engine operative landing checklist. It's getting hard for me to speak. Plan a flaps 15 landing, set VRF 15 or VRF ice. In our case it will be just a flaps 15 landing. So here we go to init ref and just set them 15. It will be 169. Okay, and I already know that it will be 5 knots of correction. So VRF ice used in different cases. I will not tell it. Let's save our time. Check the normal configuration landing distance tables and performance of flight QRA Sharper or other approved source. There is the chapter of performance in quick reference handbook, and there you need to check your landing distance. I will not pay my attention here because it will take me time to go there to check the distance, to calculate it. And yes, on real flight simulator we do it. In your real flight you need to calculate the landing distance, but it's not very important for us. Let's assume that the very small runway is okay for us for landing distance. Maintain VRF 15 plus wind additive or VRF ice minimum maneuver speed on final approach, ensure sufficient maneuver margin and airspeed for go around. The minimum wind additive is 5 knots, so I added already 5 knots. Then engine ITS is needed, use on operating engine only. We don't need engine ITS. So down to deferred items, it's complete. You may put it aside, and then you may prepare the cockpit. So first you need to set already VRF set, then set the auto brake. By the way, if you are pilot flying, you need to call to your partner, okay, you have control. He say, okay, I have control, and he or she, of course. And prepare cockpit your side. Basically, final approach course, yes, and minimum, let it be 640 or something. Now it's 640 as far as I remember for that runway. Final approach course and frequency for ILS set. And basically we have 2 ILS frequencies, and it's unidentified already, you see. On PFD, on primary flight display, we have India, November, Oscar, ILS. So it's already identified. Nice. And what we else may set? We may set. Oh, sorry, the other airport. We may set the ILS. We put it here. Let's go to legs. Runos is our point near to enter. Just 3.8 miles to reaching the final fix, and it's on the same line, so we may say 356 here, and we will have this line, so we'll see our cross track from the line. Very easy. And now let's turn to the right, more closer to Runos, somewhere there. What is happening to this autopilot? I don't really know. The radio altimeter already alive, QNH, let it be in hectopascals, because we fly in hectopascals. 1013, everything is set. So final approach course set, everything is set. Okay, my side prepare, I have controls. Yes, you have controls. And first officer performs his setup or her setup of the cockpit, his or her part, to set the minimum, etc., and many other things. And what you need to cross-check the frequency for ILS. And after that, you might go to deferred items. You have the sun checklist here. Pressurization, landing altitude. We will look at this here. It's 450. It's okay. Recall. Recall is just to check what systems are affected by your failures. So you have electrical, of course, the generator, and also yes, we have the hydraulic. Why we don't have the hydraulic engine-driven pump anymore? Because I don't know. What else? Okay, recall systems we checked. Auto brake set 3. Landing data, VRF minimums, VRF 169, minimum 640. Okay, approach briefing, and yes, of course, after you set up the cockpit, you need to perform, as pilot flying, you need to perform the briefing. So expect landing with the flaps 15 with single engine, approach and landing. In case of go around, just use flaps 1 for go around. The go around procedure review, do the go around with flaps 1, straight ahead 4,000 feet, etc. For normal landing, it will be overweight landing. Not specials about it. Use the normal technique for overweight landing as for Boeing 737. Additional ground thrust. Choose one. Additional ground thrust is needed. Yes, we quite heavy, so we go to no engine bleed landing, then below 10,000 feet. Wing ITS off. It's already off. Isolation valve closed. Let's go to isolation valve close. Go to here again. Bleed number 1 switch off. Bleed number 1 was already off. APU bleed air switch on. Do not open APU bleed air valve if the engine fire switch is illuminated. It's not illuminated, so APU bleed on and bleed number 2 off. That's it. Do the go-around procedure review. Do the normal go-around procedure except use flaps 1. Maintain VREF 15 plus 5 knots or VREF 5 plus 5 knots until reaching the flight protection altitude limit. Back angle to 15 degrees. Then airspeed is less than VREF 15 plus 15 knots or VREF 5 plus 5 or the minimum maneuver speed, whichever is lower. Yes, if you're at speed VREF plus 15, yes, you need to limit the bank angle 15 degrees until reaching VREF 15 plus 15. And also then you're airborne. If you have V2 plus 15, limit your bank to 15 degrees for single engine, of course, acceleration not only. Accelerate flaps 1 maneuvering speed before flaps retraction. Approach checklist. Altimeters. To cross check 1013, 1013, alright? Both sides. Cross check ground. Additional deferred item. Ground proximity flap inhibit. Switch flap inhibit. Let's go to flap inhibit and select it off. So to avoid the ground proximity warning switch warning system to announce to low flaps. The next will be landing checklist. So you put your courage aside once again. I don't know what's happening to this airplane, so let me guys just recycle the flight directors. I'll just recycle them to avoid this sorry. I'll firstly disengage the autopilot and then ouch. Alright, and I'll just recycle the flight directors. I have everything with me and I will follow the flight with no flight directors, just for my personal joy purpose. The speed is dropping, it's kind of terrible thing. Master caution. Air condition, we have off-schedule descent. In the real life and of course on flight simulator, you need to perform the off-schedule non-normal checklist. Here we will not perform it. The speed is dropping. Yes, it's just a flight simulator, my friends, no worries about it. I need just to put PFD somewhere in here. What is happening to the airspeed? Are we at the wind shear conditions or something? So yes, of course, in real life, you don't need to lose this speed. It's very hard to control this airplane, I don't know why. Okay, we are more or less at 3,000 feet. It's very difficult to control this flight simulator, my friends. It's much more easy to control the real airplane, especially the throttle operation. So here you just select the couple of degrees of the throttle and now your throttle will just go down and the airspeed is going down. But we are not crashing, and it's good. For raw data, you need to have the better weather than for category 1 approach, so it depends on your local regulations. But the cloud base should not be less than 300 feet. So we are approaching glide already, so we need to select the... Come on, where are the flaps? I'll select the flaps. So we are approaching the glide path and we are left of track. Let's put the approach mode here. Speed is dropping, flaps 5 please. The glide is passing, we are not stable. It's very hard to control this airplane. So start switch of course to continuous. Speed brake arm, gear down, flaps 15. It's very hard to fly actually the airplane into to control it from both like a pilot flying and pilot monitoring. It's very difficult, very difficult. So set final approach course, set let it be 3000 feet of missed approach altitude, and we are diving, just diving to reach the glide slope, and the speed is already very low. We're approaching localizer course. And yes, radio altimeter once alive once again, and it's almost uncontrollable airplane. We are flying with a huge bang over here. I don't know why, but it's very difficult to control it. The speed dropped. I don't know why, but I put the sides, the joystick full to the right, and still it's crazy. Okay, let's put pause and let's do at least something. Landing checklist. Engine start switch affected. Operating engine. Okay, continuous. I already set it on. Let's check it once again. It's continuous. All right. And speed brake armed. Yes, it's armed. And landing gear down 3 greens. Let's check. Down 3 greens. Yes, and flaps 15. Flaps 15. I think this model is terrible. I mean, the NGXU itself, I don't like it. I don't like it at all. Come on, come on. We will be unstable at 1000 feet. It's 100%. The vertical speed is very high, so at least I'll try to get ourselves to the runway, but something is wrong with the flight controls of this airplane. Definitely something is wrong. 1000, and yes, of course we are unstable. So in real life, even with the engine out, you need to go around. Use flaps 1 here, use the sync rate, etc. Of course, go around. So let's perform the go around. Go around. Set the go around thrust, and of course you need to press the toggle. Go around thrust, flaps 1. Come on, positive rate, gear up, and do the normal go around. Why it's so hard to control? Okay, let me put full to the right and let's see what happens. Why it's so... Okay, the speed is dropping. Need to pitch down a little bit. Now it's almost uncontrollable airplane. Now it's getting up. I don't know what is happening here. Very bad flight simulator, my friends. Very bad. My friends, I'm just waiting for a new model of Boeing 737NG, the PMDG model, to appear in Microsoft Flight Simulator 2020, because Prepare 3D somehow it's terrible flight simulator for me. I cannot bang, I cannot even control this airplane. I don't know why. I have the new joystick, maybe that is why, so tell me in the comment section what I've done wrong here. But yes, it's very terrible for me to fly it. On Microsoft Flight Simulator 2020, I hadn't had any kind of problems controlling the airplanes with engine, without the engine. So here, I don't know why, but yeah, very terrible. My friends, as always, follow the not normal checklist, the awesome guy checklist. First, you need to follow to like this video, then subscribe to my channel, and only after that ring the bell, whatever it means. Thank you for watching this video. Sorry about it, it was spontaneous, and it was very non-standard for me and very long. Thank you for watching me anyway, and have a great time.